Consider a box which is kept on a flat surface. So the forces acting on this object will be the weight of this object acting downwards and the normal reaction which is going upwards. Apart from these two forces, let's say there is no external force acting on this object, which means the block is at rest. Now, since the block is at rest, the friction acting on this block will be zero. Now, instead of this horizontal surface, let's say the same block is kept on an incline where the angle of inclination is theta. Now, if you observe carefully, the block will have a tendency to move downwards because of gravity. But will it actually slide down or not? That depends on how much friction the surface can provide. That will depend on the amount of friction that the surface of this incline can provide. So, theta is the angle of incline. And then, because of this incline, friction starts to act on the block. Because the block will have a tendency to go down, friction will act up the incline. For now, let us assume that the block is at rest, which means the angle of inclination is not large enough that the block starts to slide down. So let's say the block is at rest, and of course, friction is acting on the block up the incline, and that friction is static friction. Static friction, if you recall from chapter 2, is frictional force acting on the objects when they are not moving or not moving relative to the surface on which they are kept. In this case, the box is not actually sliding or slipping on the incline. So the friction will be static in nature. As opposed to this, there is another friction called kinetic or dynamic friction that acts on the object when the block actually starts to slip on the surface on which it is kept. So let me repeat, static friction will act on the object when the object is not slipping on the surface on which it is kept. Now, let's say if we keep increasing the angle of incline, then the block will have a greater tendency to slide down the incline. And as that value of theta keeps on increasing, the static friction magnitude will keep on increasing. So let's read. As theta, the angle of incline, as theta keeps increasing, that friction value increases from 0 to a maximum value. So far, we have deduced that the friction value will increase if theta increases, but friction cannot increase forever. There is a maximum value, a limit up till which friction can increase. But for now, let's say if we increase the angle theta, so the diagram looks like this. Even in this case, let us assume that the block is at rest. Now, since the block is at rest, the friction acting on the block will be static only. So, slowly and steadily, if we keep increasing the angle theta and at a particular value of theta, let's say the block starts to slide down the inclined plane, then the friction will reach its maximum value, which is called the limiting friction. So consider this case, theta is that angle of incline when the block is just about to slip. So the block is just about to move. We have already deduced that the friction value will increase from 0 to a maximum value, and the maximum value of static friction is called limiting friction. The direction of that friction is still up the incline, but the magnitude is maximum. And the magnitude of this limiting friction depends on the type of the surface and the normal reaction acting on the block. Now, let's say if we keep increasing the angle theta even more. So if we go beyond this angle, then the block will start moving downwards. So have a look at the last situation. This angle of incline is greater than the critical value when the block is just about to move. So in this situation, the block is actually moving downwards, which means the friction which is acting now on this block will not be static anymore. In this case, since the block is actually slipping, moving on this incline, the friction acting on this block is called dynamic friction or kinetic friction. So let us quickly summarize. How does the friction on a box kept on an inclined plane vary dependent on the angle of incline? As the angle of incline keeps increasing, the friction value will keep on increasing from 0. Zero friction will happen if the block is kept on a horizontal surface, so theta is 0. So as we keep increasing the angle theta, friction will keep on increasing, but it has an upper limit. The maximum value of that friction, maximum value of static friction is called limiting friction. And the formula for limiting friction is mu times the normal reaction. So there will be a particular critical angle when the block just starts to move. And if we go even beyond that angle, then the block is definitely sliding down the incline. So the friction will now be dynamic or kinetic in nature.